Now, we have to now find other clues to find out what's deep inside the Earth. And this is a really extraordinary thing. To find out now what is even deeper in the Earth, what's right in the center of the Earth, right down there, we have to actually look up instead. That's where the next clue is going to come from. If we look up, what do we see? We see the stars, we see planets, we see the sun. And you think, well, where have they all come from? Maybe they contain clues as to where we've come from and what we're made of. So let's have a look. If we look at a picture of the solar system, pictures of the solar system, this is an artist's impression, they always look like this. Here are the planets, the sun in the middle, the Earth is out here, and these are the giant planets, Jupiter and Saturn out here. They're always drawn like this as though they all line up in some way. And the answer is they do line up. All the planets orbit the sun in the same plane, going round in the same direction in more or less circular orbits. And that actually is one of the best clues there is that we all came from the same place. Where do we think we came from? If we look up at the sky, and what we see on the next picture is a picture of stars. This is the Orion constellation, famous one here, with 3 stars for the belt. And there's a big blodge down here. With the very best telescopes on the ground, what you can do is look closely at that blodge, and what do you see? You see this rather beautiful cloud. What is that thing? That is a cloud of dust and gas, and it has in it a lot of hydrogen and helium, which is left over from the Big Bang at the start of the universe, and also it has lots and lots of other elements. Those other elements come from exploded stars. And what we think is that we, the sun and the solar system, formed from such a cloud which collapsed under gravity to form the sun and the planets. Now, amazingly, we know quite a lot about what's in the sun. And Bryson here has set up a demonstration to show how we can work out what is in the sun from the light that comes out of the sun. He has here in some dishes a number of different compounds, materials, and now we're going to light it, and you'll see what happens. So what's going on is we have a number of coloured lights. And the reason they're coloured is because they're burning different things. This is boron here, lithium here, barium, strontium, copper, and sodium. And I can tell from the colour of those flames what is in those dishes. And we can do the same thing on a grander scale. We can look at the light coming out of the sun, and we can look at the colours of that light, or the wavelengths. We have quite sophisticated instruments to do that. And we can tell what's in the sun. Thank you, Bryson. Very nice demo. The sun is nearly all hydrogen and helium. 98% of it is hydrogen and helium. But it also contains nearly all the other elements, which it inherited, which it grabbed from that cloud of dust and gas when it all collapsed together to make the sun. And furthermore, we know what proportions those other elements are in the sun. All very nice. Why am I telling you all this? I thought we were supposed to be talking about the Earth, you're saying. Well, the point is that if the Earth and the sun formed from the same dust cloud, and the sun has nearly all of that dust cloud in it now, if we know what the sun is made of, well, we should know what the Earth is made of.